Okay, so let's talk about p-values, and I'll go over a few of these because there's quite a few people having the same difficulty. So let's look at this one. This is a two-tailed test since we have the not equal to. And you've got the test statistic already, but the p-value is the problem. All right, now here's what we have to remember. If the alternate hypothesis is a less than, if it's less than, so if it's this right here, then we just put this test statistic either into Excel or or look at our chart. Now, Excel will be more accurate. So it's a good idea to use Excel. Now, I'm pretty sure that what you got here was the right thing from Excel. Let me open Excel here in the background. Probably my recorder is actually in the way. Oh, I know, I've got to exit the draw feature is what it is. And so let's go to Excel. Open a workbook here. All right, and I'm just going to type equal norm.s.dist, and the test statistic was 1.582. Oh, I forgot my true. Let me do that again. I do that a lot. We always have to put the word true. All right, so it gives 0.943175. Now, if um, this is a positive test statistic, it's giving all of the area to the left of that test statistic. So let me sort of go back here and draw a picture. So, oh, let me write this down. That way I don't have to kind of flip back and forth. Okay, so 1.582 is somewhere over here on the right side of 0. And remember that 0 is the middle of the standard normal curve. So it's somewhere to the right. And when we looked this up, what it gave us was all of this area over here, 0.94. .3175. And I didn't really have room for the 5. I'll just leave it as that for the moment because you get the idea from the picture. Okay, but um, let's keep in mind that this is a two-tailed test. So here is one tail over here, and we can get that tail right there by subtracting from 1, this 0.943175. All right, so I will go ahead and do that. Subtract from 1. 0.943175 is 0.005683, and it looks like that's what you got rounded to 4 decimal places. We'll go ahead and keep it as it is for this moment, though, because we have to do one more thing. All right, so I've got that, but because this is a two-tailed test, since it's not equal to, there's another tail over symmetrically on this side right here. So we know that this area right here is 0.05683, but there's another area over here that's also part of our rejection region, and we have to take that into account as well. So in other words, we've got to double this p-value. So if we have a two-tailed test, and the test statistic is positive, then we've got to subtract what we get from 1 and then double our result. So I'm going to have to multiply this by 2. And that will give me the answer that we need. So let me go ahead and multiply that by 2. 9.1136. Okay, or rounding to 4 decimal places, 0.1137. Okay, and when I exit drawing, this is going to go away. You can always, of course, rewind the tape, or the video rather, but let's notice that's exactly what they've got for the p-value here. All right, now let me just mention one other thing, because I said if the test statistic is positive, we'll have to subtract whatever we get from 1 and then double it. If the test statistic is negative, in that instance, the test statistic negative would be over here somewhere to the left of 0. And when we look it up, we would get this area right here. So we would not need to subtract from 1. We would merely get whatever that area is if the test statistic is negative, and then we double it because we have a two-tailed test. Now let's go back up here for a second. Again, I'll exit drawing to just other p-value problems. So this is a left-tailed test, left-tailed test. We can tell from our alternate. So we should just be able to look up this test statistic and put the p-value in. So let's see. Oh, just off a little bit. Well, let's put this test statistic into Excel and see what we get here. So let me write this down before I flip over. And we'll put in equal norm.s.dist, negative 1.8157 true, and it gives that 0.0347. So it looks like if you were using perhaps the table, it pulled you off a little bit for your p-value. So use Excel. That'll help you with these p-values. Now, let's see if we've got a right-tailed test somewhere. That's left-tailed. That is a two-tailed. Just mention a right-tailed. Okay, there we go. That's a right-tailed right there. Okay, so we have a right-tailed test. We've got a greater than in our alternate, so we know it's right-tailed. When we look things up in Excel, well, my curve is horrible drawing, but when we look up 2.825, it's way over here somewhere. And when we look it up, it's going to give us all the area on the left side over here. But we want this little tail out here. So we're going to have to subtract what we get from 1. So I'll look up 2.825 on Excel. And, oh, I've got to get out of draw. Okay. So equal norm.s.dist, 2.825, true. And we get 0.997636. And if we want to, we can actually just do the subtraction from 1 right here. And there's our p-value, 0.0024 if we round to 4 decimal places. So let me go back to the problem, and it looks like you were close, and just that that little bit probably difference between the table and using Excel is making the difference. So use Excel there, and you won't have those p-value problems. So let me kind of summarize. If we have a greater than, we're going to look up the test statistic in Excel and subtract from 1. If we have a less than, we'll just look up the test statistic in Excel. If we have a not equal to, we could have two situations. If the test statistic is negative, we look it up and then we double it. If the test statistic is positive, where's the positive one? If the test statistic is positive, we look it up, subtract from 1, and double it. So I think that's going to help people with their p-values.